Hello and welcome to our webinar session today. In today's session, we will be discussing weather station integration with the Fronius Sensor card. And joining me today is my colleague Cyprian Okolo, who is our technical sales advisor for the Western African region. He's based in Lagos, Nigeria, and myself, David Mwangi. I'm the technical sales advisor for the Eastern African region. I'm based in Nairobi, Kenya. Our agenda for today, we will give you a bit of background about why you need to monitor weather data for your PV installations. Then we will get into the system itself that is integrated into the Fronius inverter or Fronius network. And we will look at the Fronius SolarNet. Then we go through the overview of the sensor card or the box, and then the sensors that are used together with that. We will also show you how it looks like when you visualize this data online in Fronius SolarWeb. We will go through the terminal overview, and then Cyprian will take you through the Solar.Service app or software, and then the commissioning process of the Fronius sensor card or box together with the associated sensors. As usual, if you do have any questions during the course of the webinar, please feel free to post them in the questions area, and we will do our best to answer all the questions that you might have. So let's get started and look at some background as far as the weather data monitoring is concerned. So one of the key things that you have to bear in mind is that for a commercial PV system, performance and reliability are critical factors that would determine the safety of energy supply as well as how fast the system can pay itself back, or what we call the return on investment. So therefore, because of this, you need to monitor the performance ratio, and this is especially so for commercial systems, whereby you could be running a system that has been financed by a bank or another financial organization, or also a system that is under critical watch by maybe other writers and other interested parties. So when you talk about the performance ratio, we are talking about what is the percentage of the actual delivered energy versus the theoretical calculated energy. So this means when you are designing the system, you had some calculations that indicated that for this kind of installation, theoretically, this is the amount of energy you expect to be delivered over a period of 1 year, for instance. But there are variations depending on quite a number of factors on site once the system has been installed. The factors that could contribute to this, among others, include the ambient conditions, and this we are talking about things like ambient temperatures. We are also talking about module temperatures. So module temperatures could be affected, for instance, by the ambient temperature, but you could also have the formation of hotspots within the PV modules because of maybe some short circuiting or breakage within the modules. So when you're monitoring this kind of parameters, you are able to know whether you have abnormal behavior, for instance, or for the module temperature, and therefore you take the necessary remedial actions. Also, irradiation is another factor that needs to be checked in terms of how your modules are converting the incoming irradiation into DC power, and of course also the wind speeds. So those also have an effect on the production of the PV system. So at Fronius, we offer you a cost-effective solution for monitoring these ambient parameters. So this is in terms of the data collection and analysis of the same, and we will tell you about this kind of solution today. So, and therefore, for this, we will talk about the sensor box, the data manager, and SolarWeb, and how these are interlinked so that you can see these parameters that are being monitored or analyzed. So in terms of the PER, or the performance ratio calculations and analysis, this would normally reveal corrective measures that should be taken. For instance, if the monitored PR is too far below the expected PR, and therefore, for you to get the right value as far as the performance ratio is concerned, it is expected that this would be analyzed after logging data over a period of time. So you cannot install a system today and in a few days or in a few weeks you want to do a performance ratio analysis. So this would be typically something in the region of maybe 6 months or a year after installation. But for that, therefore, you need data accumulated as far as these ambient parameters are concerned over that particular duration. So let's get into the actual setup of the system, and I would like to mention here that the data manager, as we know it within the Fronius Snap inverters, is a central part of the ambient data monitoring through the sensor card. Because as you know, once you have done the configuration of the data manager, this connects then to the internet, and this allows all the data that is collected within the Fronius inverter to be sent to SolarWeb for monitoring and visualization. And therefore, from there, using any smart device from your tablet, laptop, or smartphone, or even a smartwatch, you can be able to view the data that is coming from the data manager into SolarWeb. For those of you who are not familiar with the data manager, so the data manager is a plug-in card that looks like this, the image you can see here, and is the data logger, is also the web server, is also the Wi-Fi card. So this gives you a Wi-Fi access point when you're doing the commissioning of the Fronius inverter. Theoretically, you can connect up to 100 inverters to one data manager, but of course, depending on the setup, we always recommend to do an analysis of the kind of system that you are doing and to determine how many data managers or how many inverters can be connected to one data manager in that case. So like I mentioned before, the data manager will also make it possible for you to visualize the information in Fronius SolarWeb. And in addition, if you have something like a Fronius Solar TV already set up, then you can also stream data from SolarWeb to the Fronius Solar TV because of having the data manager in the setup. It has quite a number of interfaces, but as far as the weather data monitoring is concerned, we are going only to discuss the connection to the internet. Otherwise, the interaction between the data manager and the sensor card, if it's a sensor box that is used, as we are going to see later, the interaction is actually within the SolarNet ring. But if you have a data manager box instead of a data manager card, then you also have the interaction within the SolarNet ring. So, but if you have the card version of the data manager and the card version of the sensor, then you will have an interaction of the two through data communication onwards to SolarWeb for monitoring. The connection point for both the data manager and the sensor card, as we will see later, if they are both integrated into the Fronius Snap inverter, this can be accessed through the DATCOM area, or where you do the communication cabling. So as an example here, we can see the data manager with the various ports as described here. So if we had also the sensor card integrated into this inverter, then there would be a slot just below the data manager where the terminals or the connection area of the sensor card would also be shown. So here we just have to take note that when you have the sensor card integrated, you're going to do the connection of the cabling from the sensors within the same data communication area as where you do the communication, for instance, for Modbus connection to the smart meter. So as mentioned before, there are two possibilities or variation for using the SolarNet ring, and there are applicable components. So in this example, we are seeing two variations whereby we have the data manager box. So this is the data manager box that is operating outside of the inverters, or we have the data manager operating outside of the inverters, or another variation where we have the data manager operating within one of the inverters. So it is integrated in this case as a card. So in this case, the first example here, we have a data manager box, but in the second example, we have it integrated as a card version in an inverter. So within the SolarNet ring, so if it's a box version, then that forms part of the communication that is required within the SolarNet ring. And if it comes at the end of the communication loop, then you need a termination plug, and at the end of it, and at the beginning of the communication loop, you also need a termination plug. Similarly, for the inverters whereby they are operating within an inverter that has a data manager integrated, the end and the beginning of that must also be terminated also through the termination plugs. So what is important here to note is that this SolarNet ring is a protocol for communication for all Fronius inverters. And by this, I would like to emphasize this is only for Fronius snap inverters currently. And it's a Fronius SolarNet ring is a Cat5 communication protocol only. So here you need Ethernet cable from Cat5 upwards. It's a ring topology, meaning that when you have several inverters, then you are going to daisy chain the communication cable from one inverter to the other. So it has an in and out RJ45 connection. If you have several inverters, then each inverter within this SolarNet ring requires a unique inverter number. So and for snap inverters, then the inverter number is assigned within the display of the inverter itself. Having said that, let's have a look at the sensor card or box overviews. So as mentioned, we have two variations of the sensor application or the sensor integration. So this can be done either as a sensor card, as we can see here to the left top, or it can also be done as a Fronius sensor box. You have the possibility to connect into any of these different types of sensors, and the transmission of the data, once it is converted appropriately within the sensor card or sensor box, is then sent to the Fronius data manager, which then forwards the information to Fronius SolarWeb for visualization and monitoring. Up to 10 sensor boxes or cards are possible within one system, but then it depends on how many parameters or ambient parameters you want to monitor. So the question then would be, when is it appropriate to choose a sensor card versus a sensor box? So as you know, as already mentioned, when you connect the sensor box as part of the SolarNet ring, you're going to make use of the Ethernet cable. And with an Ethernet cable, you can go to a maximum distance of about 100 meters from one component to the next. However, looking at the different sensors that are possible to be connected, some of them come with a predetermined length of cable which should not be extended. And in some cases, most of these do not go above 10 or 20 meters at most. So if the distance from where this particular sensor will be to the inverter where the sensor card is integrated will be more than the sensor cable length, then it will be better off to integrate a sensor box instead of the sensor card, because the sensor box then allows you to be as close as possible to the sensors without any modification on the sensor cabling. So as mentioned before, when you want to integrate the sensor card into the Fronius inverter, you are going to integrate it into the same area that accommodates the data manager cards. So here, this is the part of the inverter with the display, and this is what we refer to as the reservoir of the inverter. So you can see the LCD here, and once you open up the inverter front cover, you're able to access the slots where you are able to integrate or retrofit the sensor card. And yeah, so you can take any of these two slots for integration of the sensor card. Looking at the general data of the sensor box, so we say that you can integrate it outside of the inverter. What is important to note here, for instance, the degree of protection is only IP20, and therefore it means that this would require some protective enclosure once you have it as part of the SolarNet ring, because you know the inverter is already IP65 or 66, and therefore the sensor card, once integrated into the inverter, acquires the same degree of protection. But for the sensor box, it's only IP20. It means that it needs protective enclosure. In terms of power supply, this will be about 12 volts, but do not worry about that because that is applied directly from the SolarNet ring communication cabling. Energy consumption is about 1.3 watts. And in terms of sensors that can be connected into it, we have, as you're going to see, quite a number of them, from the temperature sensors that have an operating range of about -25 degrees to 75 degrees Celsius. The accuracy is within 0.5 degrees Celsius with a resolution of about 1 degree Celsius. In terms of voltage, maximum is about 5.5 with a frequency max of 2,500 hertz, and minimum pulse duration 0.25 milliseconds, and the operating thresholds for on and off as far as low and high are concerned is 0.5 volts and 3 to 5.5 volts on the higher side. For current measurements, as far as the current input is concerned, you can do the measuring within two ranges, from 0 to 20 milliamperes or from 4 to 20 milliamperes. So here the max is about 20 milliamperes, and the accuracy is within 5% of the meter reading. For insolation, we have the possibility to do the measurements within three ranges here. So we can do from 0 to 100 millivolts, then from 0 to 200 millivolts, but to a maximum of 1 volt. So you cannot exceed an input of 1 volt to the Fronius sensor ports or card. So accuracy here will be within 3% of the meter reading. So let's now have an overview of the various sensors that you can use with the Fronius sensor box for weather data monitoring. So we have two types of temperature sensors. So we can see here to the top, this is the ambient temperature sensor. And we also have here at the bottom, the module temperature sensor. To the left, we also have a wind sensor and an irradiation sensor to the top here. So these are, as far as the inputs are concerned, we have one voltage sensitive input for irradiation. We have two temperature inputs for the PT1000 sensors, and then we have two digital inputs, which are freely configurable. And we also have one current sensitive input that is also configurable freely. In terms of the terminal overview of the sensor card or sensor box, once you have it, so it's very well labeled and you cannot make any mistakes. So we have terminal 1, for instance, would supply about 5 volts. This is a digital channel. Then 2 and 3 are also digital, but inputs for kilowatt hour or meters per second measurements, as we are going to see later. Then we have terminal 4 for ground connection for the digital connection 2 and 3. Then we have terminal 5 is an analog input for current signal. Then 6 is and 7, these are for temperature measurement with the PT1000. And number 8 is an analog input for voltage, and this can be used for something like irradiation, for instance. As far as the digital inputs are concerned, we would like to give you some channel assignment examples here. So if you look at the connection for the digital inputs, we have talked about channels 1 and 2. Here you can connect an electricity meter or a wind speed sensor. And if they do not have their own power supply, then you should connect them starting with the 5 volt output. So this 5 volt output will be shared between digital inputs 2 and 3. And therefore, the other return line is only connecting to the assigned D1 and D2 inputs. If, on the other hand, that particular sensor has its own power supply, then it should only be connected to its own particular input, which is either 2 or 3, and then the ground connection will be shared between the two sensors for the digital input. So as a functional principle using the electricity meter, the sensor card basically counts the pulses of electricity and then calculates the kilowatt hour being used from the number of pulses that are being counted. As far as the width sensor is concerned, the functional example here is that the Fronius sensor card counts the pulses from the width sensor, and using a calibration factor, then the sensor card is turning these pulses into the applicable meters per second kind of data that is sent to the data manager. An example for the analog input. So here we are looking at, for instance, a humidity sensor and how this can be integrated into the Fronius sensor box or card. So a humidity sensor with a current signal is an active sensor that sends out current that rises as the humidity increases. And therefore, the level of humidity will be derived directly from the measured current. So therefore, the Fronius sensor card measures the current between the two terminals and therefore gives an interpretation of what is the humidity level. That is when you have a humidity sensor integrated. So the temperature sensor, on the other hand, so if you look at the design of the PT1000 sensors, so they consist of some resistors inside whose resistance value is changing in response to the changes in temperature. And therefore, to interpret this data or to read out this data, the Fronius sensor card or box is measuring the voltage drop across the resistor when a constant current is flowing through the resistor and calculates the temperature from this voltage drop. So therefore, as mentioned, you can do monitoring or measurement of the ambient temperature as well as the module temperature by connecting to terminals 6 and 7, and these are specifically only for PT1000 type of temperature sensors. In addition, you can also do analog input voltage as an input voltage signal. So as a functional example or functional principle here, the irradiation sensor, of course, with a voltage is an active sensor that outputs a certain voltage with a rise or drop in the irradiance levels. So therefore, the sensor box is looking at the voltage across the terminal, and this drop or rise is used to derive the irradiance at that particular moment in time. So when it comes to the online visualization, you can directly be able to see a graph of the particular parameter that is being monitored. So in this particular view, we have the monitored irradiation level. So here we are talking about the watt per meter square scale here. And you can see it through the day, how this has been behaving. And for this particular time period, we are talking about an irradiation level, for instance, at around 7:40 in the morning. If you look at it, this was just about 193 watts per meter squared. But of course, this is changing through the day. So you can see it's peaking just about 900 watts per meter squared at around 12 noon. And then, of course, as expected, you can see a drop all the way to the evening. When it comes to temperature, you can also be able to see both the ambient temperature and the module temperature. So the module temperature here is shown in the green curve, and the ambient temperature is shown in the blue curve. So we can see what is the interaction like between the ambient and the module temperature. And as I said before, if the module has some abnormal behavior, you would be able to pick it up. Maybe there has been some development of hotspots and things like that. So you can get an indication depending on the output of the modules as far as the irradiation is concerned and the ambient temperature, because this sensor will be able to tell you at this level of, let's say, ambient temperature. As you can see, ambient temperature of about, let's say, 20 or 25 thereabout, you can see the corresponding module temperature. So if you see that the behavior as far as production of your modules is not with line with what the module temperature sensor is reporting as expected, then you can see that there's something that needs to be done as far as maybe looking for hotspots or things like that as within the modules are concerned. So having said that, I would like to hand over to my colleague Cyprian, who will take over and talk about the Fronius Solar.Service and the commissioning process. So Cyprian.
Yes, indeed. Thanks a lot, David, for your wonderful presentation. I will be taking over from here as I take over presentation rights. So I want to believe now that you can all see my screen and hear me clearly. So we shall be continuing with Fronius Solar.Service. So if one may ask, what is Fronius Solar.Service? So Fronius Solar.Service basically is a tool, an app that is basically used for analysis, configuration, and servicing. It is a one-stop tool that can be used to access the Fronius Sensor card and then do the configuration and, of course, monitor all the sensors and, of course, get further details of the entire system. So through it, you can actually have a quick overview of the entire system status. You have a clear visualization for easy pinpointing of defects if they come up. And of course, in this case, it is easy to set the most important inverter functions and parameters. All settings and any servicing and maintenance work can be carried out on site as well as remotely using the Fronius Solar.Service. And then, of course, you have transparent listing of status codes. So having said that, why is this necessary? So why Solar.Service? Meanwhile, we have left a link here for you because it's freely downloadable. So it's a compressed folder, so you have to download, extract the folder, and then install the app. Good. So continuing, why Solar.Service? It saves time and money. This is because the system status of all Fronius components can be viewed at a glance. And the fact that numerous settings and servicing can be done or carried out remotely saves a lot of time and money. It is convenient in the sense that all system data can be easily displayed on your PC or any tablet or the monitoring device you're using. And then all you need to do is just to download the application, just as I've left the link in the previous slide, and then you can now gain access to the components straight away. It is efficient because component faults can be identified and rectified more quickly. This, of course, results in shorter downtimes and higher yield. So going further, let's look at how the configuration takes place with the configuration diagram, as you can see. So configuration can either be done by hardware, that is by connecting the inverter with your monitoring device, that is your laptop in this case, with a LAN cable via the LAN cable via the RS-232 or USB port, or it could be done remotely by, of course, connecting it using the wireless LAN or Wi-Fi as we know it. But of course, you'd have to ensure that the inverter and the device should definitely are in range of communication, as in communication range. Of course, this is done via internet for remote maintenance. Okay, so going forward, let's now look at how the communication happens with, of course, the data manager. As my colleague David has earlier said, the data manager is the communication medium of any Fronius system. So we'd have to ensure that there's a data manager installed or installed in the system. So once that is done, you can now communicate with any monitoring device. In the case where you have multiple components, that is multiple inverters, please ensure that only one data manager is turned on. If there are data managers in the system, please ensure that only one is functional. So this can be done by simply turning off the other data managers in the other inverters. So once this is done, you can now have access, seamless access to the system via, of course, with your monitoring device. So basically speaking, if, for example, as you can see in this case, you have the Fronius Sensor card installed inside this inverter, if there's any query or inquiry for data, it will have to go through the data manager, that is through inverter 1, and then the inquiry is made off for the sensor or whatever parameter is being made, then this information is now fed back through the data manager to your monitoring device. So that's basically how the communication goes. So this is in a case where we have, in this case, 4 inverters with the sensor card installed in one of the inverter. But in a case where you're using the sensor box, as you can see, it can also be connected this way. So you have a sensor box. Of course, as David has earlier pointed out, you'd have to interconnect them using the SolarNet ring, as you can see, from out to in of the subsequent inverters. Then the last inverter gets has the stop plug connected. Without these stop plugs at the end of each communication component, there won't be communication in the system. So it has to be a ring, a full or closed ring connection. So as you can see in this case, once you ensure that your SolarNet ring is up, you can now connect your respective sensors. As you can see in this case, the temperature, irradiance, and wind or speed sensor has been connected for this particular example. So just giving us the idea of how the communication is in perspective. So going forward, let's now take a look at how we can commission the system. So first off, we'd have to start off by switching on or turning on the Wi-Fi access point of the inverter. So we'd have to activate the Wi-Fi access point of the data manager via the inverter display. And then we can do this by simply scrolling to setup. Once you scroll to setup, we can now select it. And then once you do that, please choose the Wi-Fi access point option. Once that is done, you can now activate the access point, because in this case, it will be asking you the question to activate Wi-Fi access point. Once you click on enter, it would now automatically open the Wi-Fi access point. And then please note the Wi-Fi access point name, as you can see in this case, and the password for your device. So once these are noted, you would now go ahead to connect to the inverter's network. So to connect to the inverter's network, please locate the network settings on the taskbar. This is usually located at the bottom right corner of the screen. That's if you're using a laptop. So, or by using the Windows search function. Then secondly, you now select the Fronius access point from the list of available networks. So like I said earlier in the previous slide, ensure that you take note of the access point name, as you can see in this case, and then of course note the password. So most importantly, note the access point name, because that is what you would ensure that it rhymes with what you are selecting. Otherwise, you'll be connecting to a different inverter. That is, if you have multiple data managers. Okay, so once that is done, you can now go ahead. But before that, please note that the access point must be active and your computer must be in the range of the access point signal. That's very, very important. So next up is to enter the access point password. So this is usually 1 through to 8. So once you do that, you now can now connect. So after connection, you can now go to your Solar.Service app that has already been installed in your system, in your PC. It usually comes up as with this icon. So once you double click on it, you now have access to the domain. Of course, once the program is started, next thing you'll have to do is to add or click on add connection. So by clicking on add connection, you're basically trying to add the data manager or the inverter that has the data manager, which now represents the system, onto the platform the Solar.Service platform. So once you click on add connection, you can now go ahead and enter the IP address. So the IP address is 192.168.250.181. So once you enter that, you can now click on add. Before then, you can of course choose to name the system, probably a familiar code or probably related to the site of installation. So once you do that, click on add, and then it would now add the system. And then of course, please note that this is the data manager's IP address. So for your information, the sensor card does not have an IP address. So going forward, once the IP address has been added, you can now go ahead and click on it. And then once you click on it, you would now finally have access to the system and of course, all the components in the system, be it the data manager. If there are multiple inverters, you would have access to them. And then most specifically for this particular presentation, the sensor card. So once you have the sensor card here popped up, you can now click on it. And then once you click on it, it will now take you to the sensor card homepage where you can now select setup menu. And then by selecting setup menu, it will now lead you to a landing page where you can now do your configuration, just as we can see in this case. So you have all your channels available for configuration, the 2 temperature channels, the insolation channel, the 2 digital input channel, and then of course your current based channel. Please ensure that you select your favored or desired SI unit. So for the temperature, as you can see in this case, it's either in Celsius or Fahrenheit. For the insolation, is fixed. It's of course watt per meter squared. But then you would have to select the measurement range. So the measurement range usually varies from 0 to 100 millivolts, 0 to 200 millivolts, or 0 to 1 volt. It is necessary, of course, to enter the calibration factor, which is usually located on the label of the insolation sensor you are making use of. Good. So next up is the digital input and the current-based input. So this, it comes in as a very, very flexible channel. Because they are freely configurable and there's so many quantities that you can actually measure in this case. So you have them all represented in their respective SI units. So just going through a few, you can actually measure energy density, voltage, irradiance, temperature. Yeah, so in the case where you want to measure or you have more module and ambient temperature measurements that you want to make, you can of course utilize any of these digital inputs in addition to what you already have here. You can also measure pressure, volume. This comes in very handy when you want to keep note of the diesel level, for example, of a remote site, probably a mining site. This comes in really handy and very, very helpful. You can also have your RPM, that's revolution per minute measurement, energy, battery energy density, apparent power, and of course, reactive power. But then also note here that the calibration factor for the Fronius wind sensor is represented as 1.5 being equivalent to 1 kilometer per hour, or 5.22 being equivalent to 1 meter per second. Yeah, as you can see in this case as selected. So same variables can be measured across the digital, and the current output. So once you've made your selections, and for the current, just to note here, you can actually, I think David has mentioned it already, you have 2 measurement ranges, that is 0 to 20 milliamp or 4 to 20 milliamps. So select whichever is your preference. So once all your configuration has been done, please ensure that you select save. Once you click on save, your settings will be saved, and then you can now monitor seamlessly using the Fronius Solar.Service. Good. So for further information, I would like to give you info on how you can easily get information, because we tend to get these inquiries on a frequent basis. So just going to put you through how you can get information from our website. Please note that Fronius has 3 business units: the welding, the solar energy, and the charging business unit. So if you find yourself on our website looking for information, please select business unit, go to solar energy, and then since we're specifically making this presentation for installers and partners, you can just go to installers and partners. And then if you're looking for info about what you can get from this, it will take you straight to the landing page for installers and partners. There you can have access to information on products and solutions, technical data, information data, of course, service and support downloads, and contact. So just to put it in perspective, you can just click on this link. It will take you to our website where you can, of course, have access to all this info. So just to put you through, yeah, so basically just going to take you through for example purpose. So select business unit, select solar energy, and then just as explained in the slide, select installers and partners. It will of course take you to landing page where you have info about our products and solutions. So for products and solutions, you can have access to residential and commercial energy solutions, monitoring and digital tools, off-grid and backup solutions, and then of course other features. For technical data, you can get of course technical data and data sheet for all our inverters, system solutions, monitoring, and other accessories. For Information Center, you would have information about our current and upcoming trainings, webinars, and of course other virtual fair. And then for service and support, you can get technical support info, warranties, trainings and webinars, and of course our FSP program. For downloads, here you can get all the probably necessary documents that you want to download. It also includes various softwares and updates that are also free to download. And then finally, if you want to have information about how to contact your nearest sales partner or technical support, you can as well do so. And then, of course, you have our social media handles here that is available for you to search through. Good. We also have recordings available on our homepage where you can have access to operating and installation instructions. And then on our YouTube channel, you can have access to our how-to and installation videos. Most importantly, we also have webinar recordings. So we have a collection of all the webinars that we have aired so far, including this one eventually. So this you can have access to on our Sub-Saharan Africa playlist, which can be accessed through this link. And yeah, so with this, you're able to get all the information you need. And then if you want to make inquiries with respect to the technical sales trainings or after sales service, please make use of this information on display. And then if you would rather contact the TSAs directly, you can do so with regards to your regional TSA. That is myself, Cyprian Okolo, for the Western Africa region, Byron Kotza for the Southern Africa region, and then of course, David Mwangi for the Eastern Africa region. So with that, we have come to the end of today's presentation. We sure hope you enjoyed the content. And until we come again next time in the next presentation, we want to wish you a very pleasant day. Thank you and goodbye.